Welcome to Refraction with me, Mrs. Allforce. You already know that light travels in straight lines. You also know how light travels through matter. We explored transparent, opaque, and translucent materials. A transparent material is a material that light can pass through, like clear plastic, water, glass. They're clear, you can see right through them. They transmit light. Opaque objects don't let the light pass through. They block or absorb the light. Those are the objects that actually make shadows, like in our shadow play lab. Light is not transmitted through opaque objects. Finally, we explored translucent materials. Those are materials that light can travel through, but it's scattered and objects can't be seen clearly. Only some of the light is transmitted, so it appears scattered and it's going in different directions. So objects can't be seen clearly, like in this milk container. Light travels in straight lines, light can travel through a vacuum, and light can be reflected, refracted, and absorbed. Light travels at a speed of about 300 million meters in 1 second. That's 186,000 miles per second. We also know that it's faster than sound. But what you might not know is that it travels the fastest through a vacuum. Remember, sound couldn't travel through a vacuum at all. Light travels the fastest in a vacuum and the slowest through a solid. So you can see my chart here, it goes from fastest to slowest. So we have vacuum, and then gas is a little bit slower than vacuum. And we have liquid, which is slower than the gas, and then our solid, which is the slowest. That's the speed of light through different materials, or nothing at all if you're talking about a vacuum. Light is reflected when the light rays bounce back, like on this curved mirror. Light waves are absorbed when they are stopped or blocked, like on that piece of wood. Smooth and shiny surfaces reflect light well, but bumpy surfaces do not, because those light rays bounce back in many directions. So we already said that light can be reflected, refracted, and absorbed. But I wonder, what is refraction? Light travels in straight lines, but it can be refracted or bent. Refraction occurs only when the light rays enter or leave a substance at an angle. If the rays are straight up and down, they do not bend. When I think of refraction, I like to think of someone doing a back bend, because refraction is the bending of light rays. Mrs. Kelly's doing a wonderful impression of refraction, don't you think? Light travels faster in some materials than in others, and some materials refract light to a greater degree than others. When light rays pass from one material to another, they may speed up, slow down, or change direction. To see how this happens, let's have demonstration time. What I have here is my tray, a pencil, and then a little bit of Play-Doh to block that pencil. So what we're going to do is we're going to roll that pencil down the sloping surface. And when I slow one end down on the pencil by placing that obstacle in its way, The other end of the pencil is not slowed, so it swings around. The direction of the pencil changes. This example is just one way for you to visualize how light travels faster in some materials than in others, and some materials refract light to a greater degree than others. But whenever light rays pass from one material to another, they may speed up, slow down, or change direction. Let's go ahead and explore refraction more with the Broken Straw Lab. First, I want you to get a transparent glass or bottle. Then, fill it halfway with water. Insert a straw or other item inside the glass or bottle and observe the broken straw. Why does the straw look broken? It's refraction. Light travels in straight lines, but it can be bent when it enters a substance at an angle. With the broken straw, the light slows down as it hits the water, refracting the light and making the straw appear bent when it is not. Let's look at it in a different way. We know that refraction is the bending of light rays. So if you look at that image, A hits the water first. B travels faster, that's the dotted line, until it hits the water. Then A and B travel at the same speed, but the direction of the light ray has changed. So basically, the light ray was traveling really fast through the air, and as soon as it hit the water, it slowed down, and that refracted or bent the light. A person who is spearfishing would experience the same phenomenon. They can see the fish by looking in the air, but where it appears to be in the water is different from where it actually is. That's because light is refracting as it travels from the air to the water. Have you ever tried to grab something in the water and realized it's not where you thought it was? So we know the straw is not really broken. It's just that the light is being bent or refracted as it moves through the glass, the water, and the air. So where in this image is light traveling the fastest? Remember when we talked about the speed of light through different materials or not materials when it comes to a vacuum, since a vacuum is nothing, not even air? It's fastest through a vacuum, second fastest through a gas, then we're going slower liquid, and slowest through a solid. Well, this light is not traveling through a vacuum. There's no vacuum here. But it is traveling through a gas, a liquid, and a solid. Which of those would be the fastest? It'll be the fastest traveling through a gas. But it looks bent because it goes from one material to another. Let's check out the disappearing paperclip lab to see if we can better understand refraction. First, get a paper clip and a glass or a plastic cup. Next, fill the cup halfway with water. Put the paper clip under the cup. So it's not going in the water this time, it's going under the cup. Put your head near the glass and look at the paperclip at different angles until it seems to disappear before your eyes. The paperclip has vanished. But why? It's because of refraction, of course. The light bends when it goes from the air to the water, and the speed of light slows down, which makes the paper clip seem to disappear. It's refraction. All right, we're going to explore another item that refracts light, and those are prisms. Prisms. A prism is a piece of transparent material that is shaped like a triangle. When light shines on a prism at a slant, the light rays bend as they move through the prism. Each ray bends a different amount, causing a band of colors, or spectrum, to exit the prism. It breaks light up into the colors of the rainbow. Tiny droplets of water in the air are prisms too. That's why we see a rainbow after a rainstorm. Sunlight, or white light, is made up of all 7 colors of the visible spectrum. The 7 colors include red, orange, yellow, green, blue, indigo, and violet. Sometimes we call the visible spectrum Roy G. Biv. That's the first letter of each color. These colors are always in the same order on the spectrum. A prism separates white light into colors. White light enters and light rays refract as they move through the prism. We can see the visible spectrum, all the colors of the rainbow. What else refracts light? Oh yeah, lenses. Lenses refract light. A lens is an object that refracts light. A lens can make objects appear larger or clearer. Do you know of any lenses? I bet you do. A microscope, eyeglasses, and telescopes all use lenses. A lens is usually made of plastic or glass. It is curved in some ways so that it refracts light. A convex lens is thick in the center. It bends light rays inward to a focal point. This lens makes objects appear larger. Examples of convex lenses include magnifying glasses and microscopes. A concave lens is thin in the center. It bends light rays outward. This lens makes objects appear smaller. People who are nearsighted wear glasses with concave lenses. A peephole in a door is another example of a concave lens. So you can see the convex and concave lenses there. So the convex lens is thick in the center, and the concave lens is thin in the center. Let's try a lenses lab and see if we can learn a little bit more about refraction using lenses. First, you're going to need to get a glass or a plastic cup. Then, fill it with water. Next, draw or print an arrow on a card and prop it on a table. Place the glass of water a little to one side of the card and a few inches in front of it. Now stoop down until your eyes are on a level with the arrow. Notice which way the arrow points, and then slide the glass until it is between the card and your eyes. Which way is the arrow pointing now? The arrow points in the opposite direction. Now slide the glass of water in and out a few times and watch the arrow. What happens? The size of the arrow changes. But why? It's because the glass of water acts as a lens. It's refracting the light. Actually, when the arrow changed directions, it acted like a convex lens. And when the arrow changed sizes, the water also acted as a convex lens. It's time for refraction review. So today we learned that refraction is the bending of light rays. Refraction occurs when light enters or leaves a substance at an angle. When light passes from one material to another, they may speed up, slow down, or change direction. Like in the broken straw, the light was traveling faster until it hit the water. It's traveling the fastest through that gas, which is air. And then when it hit the water, the light slowed down and made the straw look broken. Light can be reflected, refracted, and absorbed. You've already given me examples of objects that reflect light and absorb light. Be on the lookout now for examples of refraction. What can you find? All right, that's all for me. Take care. Peace.